And welcome to the AI with Arun show. In this episode, we are going to explore a development that sits at the very edge of healthcare innovation, a project that would fundamentally reshape how we think about medical training, diagnosis, and even the very structure of a hospital. We are taking a deep dive into China's agent hospital, or I should say AI agent hospital, a revolutionary concept developed by a multidisciplinary team at Tsinghua University's renowned Institute for AI Industry Research. As we'll see, this is an attempt to build an entire self contained medical world powered exclusively by AI. So, what exactly is the AI agent hospital? First, it's critical to understand that this is not a conventional hospital with walls and beds. It's a fully immersive, closed loop virtual ecosystem powered entirely by autonomous AI agents. Think of it less as a place and more as a simulacrum, a simulation of reality so complete that it functions as its own world. Its primary purpose is to serve as a high speed training environment for these AI agents. The system allows an AI doctor to accumulate the equivalent of years of clinical experience in just a matter of days. It achieves this by treating tens of thousands of simulated patients, enabling a process of continuous improvement through self reflection and learning from every single case. And this simulation is comprehensive. It models the complete patient journey from the very first moment an AI patient feels sick through diagnosis and treatment all the way to post treatment follow up. And crucially, the entire cycle operates without any human involvement in its core function. To understand the patient experience, we have to look at it on two separate but connected levels. First, there is a virtual patient journey within the simulation itself. This is a meticulously architected end to end process. An AI patient agent gets sick, is triaged by an AI nurse, consults with an AI doctor, undergoes tests, and receives a treatment plan. But the fundamental goal of this journey is not healing. It's to function as a powerful data generation engine, creating the very information needed to fuel the AI's evolution. The second level is the projected human experience, the long term vision for how this technology will be used by real people. Here, the goal is to leverage the highly evolved AI as a powerful tool to enhance healthcare accessibility and efficiency. For us, the experience is envisioned as an intelligent digital front door to the healthcare system, accessible right from our smartphones. The aim is to slash wait times, provide instant remote triage, and remove the administrative hurdles that so often prevent people, especially in underserved regions, from getting the care that they need. So, what makes Agent Hospital technically unique is its core methodology. It's built on a few key concepts that set it apart. The overarching paradigm is called SEAL, which stands for Simulation Based Evolutionary Agent Learning. This is a strategic masterstroke. It decouples AI development from the dependence on vast real world patient datasets. In Western countries, accessing this data is a major bottleneck due to privacy regulations like HIPAA. The SEAL methodology circumvents this by creating a virtual world that generates its own unlimited context rich data. This allows the AI's training to happen at a speed and scale that would otherwise be impossible. And the engine driving this learning within the world is the MedAgent-Zero framework. This is a strategy that enables the AI doctor agents to evolve on their own. It works by building two key knowledge stores: a medical record library filled with successful cases to learn from, and an experience base where it locks lessons learned from reflecting on and correcting its own failures. This self correcting, experience driven model is a radical departure from traditional AI learning or AI training methods. The strategic implications of this project are profound, extending far beyond the realm of pure technology. It has the potential to completely revolutionize medical education by providing a scalable, risk free environment for training human doctors. It also opens the door to new models of low cost, high access telemedicine that could democratize healthcare on a global scale. This initiative is also deeply aligned with China's national strategy to achieve global leadership in AI, backed by massive state level support. It's a formidable state supported effort to redefine the future of digital health. But the project's leaders are clear. The ultimate measure of success won't be its performance in a virtual world. Success will be measured by its ability to deliver tangible, equitable, and trustworthy improvements to the very real human patient experience. So let's zoom in on this new paradigm. The agent hospital moves beyond using AI for discrete, narrow tasks like analyzing an X ray. Instead, it creates a comprehensive simulated healthcare ecosystem, a potential blueprint for the hospital of the future. Inside this AI hospital town, as the creators call it, AI doctors diagnose and treat AI patients, all supported by AI nurses. The simulation is incredibly detailed, encompassing 21 different clinical departments and capable of processing thousands of patient cases every single day. This entire virtual facility operates with zero human staff, functioning as a self contained universe for the practice and evolution of artificial medical intelligence. It's important to understand that this project is not happening in a vacuum. It's deeply embedded in China's national ambitions. The country is projected to invest over $1.4 trillion dollars into AI development by 2030, with healthcare being a top priority. This initiative is also a direct response to some of China's most pressing healthcare challenges: a rapidly aging population, a shortage of qualified doctors, and major gaps in care between wealthy cities and rural areas. These numbers give you a sense of the scale. The simulation covers 21 clinical departments, from cardiology to pediatrics, and its speed is staggering. The platform can simulate the treatment of 10,000 virtual patients in just a few days, a caseload that would take a single human doctor at least 2 years to handle. This is the power of that time compression capability we talked about. The project is driven by a clear dual mandate, combining pure research with very practical goals. The primary objective is AI research. It's designed to be a digital crucible, a self contained environment where AI doctor agents can evolve through massive scale iterative practice, pushing the boundaries of what medical AI can do. The secondary objective is medical education. The platform serves as a hyper realistic, completely risk free training ground where human medical students can practice their clinical skills on an endless variety of simulated patients, encountering rare disease and complex cases without any chance of harming a real person. But the long term vision is practical healthcare delivery. The ultimate goal is to transition this technology from the virtual world to the real one, making it a tool for telemedicine and public health planning, like predicting the spread of infectious diseases. The idea is to cultivate a new generation of AI collaborative physicians, doctors who are trained to work alongside these powerful systems in the clinics of the future. Now let's step into the engine room and look at the technology that powers this entire system, the MedAgent-Zero framework. As we mentioned, the foundation is the SEAL paradigm, simulacrum-based evolutionary agent learning. It consists of two key stages. First is simulacrum construction. This is the creation of the virtual hospital world, but it is not static. It is generative. The system uses large language models guided by medical knowledge bases to dynamically create the hospitals, its rules, and a diverse population of virtual patients with unique systems and histories. The second stage is agent evolution. This is the core learning process where the AI doctors continuously improve their skills within this world. The key principle here is that the AI evolves through self play and feedback entirely within this virtual world, with no need for human intervention or hand labeled data. Now, let's walk through how an AI doctor agent actually learns using the MedAgent-Zero strategy. The picture that you see on your screen, it shows the continuous loop. It starts with a patient interaction. The AI doctor consults with a virtual patient, orders tests, makes a diagnosis, and prescribes a treatment. From there, the path splits based on the outcome. If the treatment is successful and the patient recovers, it follows the success pathway. The entire case is stored in the medical records library, where it serves as a positive example for future cases. But if the treatment fails, it triggers the failure pathway. The AI agent initiates a reflection process to figure out what went wrong. This reflection leads to the experience base. The AI formulates a new rule, a lesson learned, to prevent that specific medicine or mistake in the future. This lesson is then validated and added to its knowledge. The entire process is what is known as zero label learning, because the labels of success or failure are generated organically by the simulation's outcomes, not by humans. Of course, the critical question is how well does this perform? You may have seen the headline figure of 93.06% accuracy, which we also reported in the AI with Arun show on our weekly Sunday news. It's important to contextualize that. This was achieved on a specific subset of the MedQA dataset, which is based on the US Medical Licensing Exam, the USMLE, and is focused specifically on major respiratory diseases. But the internal metrics after the AI treated about 10,000 virtual patients are perhaps more revealing. As you can see on the chart, the agent achieved 88% accuracy in selecting the right medical tests, a very impressive 95.6% accuracy in making the correct diagnosis. But its accuracy dropped to 77.6% when it comes to choosing the correct treatment plan. This reveals a significant diagnostic therapeutic gap. The AI is excellent at identifying the problem, a core strength of modern LLMs, but finds it much harder to determine the optimal solution, which is a more complex multivariable problem. This suggests that in the real world, the AI may be ready to serve as a powerful diagnostic assistant long before it can be trusted with autonomous treatment decisions. Now let's trace the complete journey of a single virtual patient, which is the fundamental mechanism for all of the AI's learning. Step one is the pre-hospital phase. A virtual patient is generated and gets sick with a clinically possible condition. It then seeks care and is triaged by an AI nurse who directs it to the right department. Step two is the in-hospital consultation. The patient engages in a detailed conversation with an AI doctor who must actively ask questions to gather all the necessary information. Based on this, the doctor orders examinations. Step three is in hospital treatment. The doctor synthesizes all the data to make a diagnosis and creates a treatment plan. The patient then gets its medication and is discharged. And step four is the post hospital phase. This is the most important part. The patient's recovery is simulated. If it recovers, it provides positive feedback, and the case becomes a success in the medical record library. If it does not, it returns to complaint, triggering the failure pathway, reflecting and learning. So, how does this all translate from a virtual simulation to the real world? And how will this technology actually impact human patients? The transition is planned to be gradual and cautious, with the public pilot expected to begin in late 2024, early 2025. The key is to this is a partnership with a real-world facility, the Beijing Tsinghua Changguang Hospital. The plan is not to replace human doctors. Instead, they envision a hybrid model embedding the AI into the hospital's existing digital infrastructure as an intelligent assistant. The technology will support nearly every journey, from streamlining admissions and providing predictive alerts for conditions like sepsis to assisting with diagnostic imaging and reducing administrative work for nurses. Interestingly, the project also includes a collaboration with Tsinghua Academy of Arts and Design to incorporate healing architecture into the physical hospital. This is a deliberate effort to balance high-tech efficiency with the high-touch, human-centered need of patients, assuming or ensuring that the hospital of the future does not feel cold or impersonal. So what will it look like for a patient? The primary access point is envisioned to be the smartphone, aligning with the goal of making healthcare as accessible as checking the weather. The interactions will be conversational, using voice or text chat through a dedicated app. You'll describe your symptoms just like you would to a person. This interface will serve as the intelligent digital front door we mentioned earlier. It will conduct initial assessments, provide advice, handle scheduling, and seamlessly escalate to a human doctor when needed. Let's imagine a hypothetical journey to see the value proposition. It starts with remote triage. A patient in remote area feels unwell. Instead of a long journey, they open an app. The AI asks questions, assesses urgency, and provides immediate advice or schedules an appointment. This immediately solves for geography and wait times. Next, during an AI-assisted consultation with a human doctor, the AI acts as a co-pilot. It can transcribe the call, summarize the patient's history, and even suggest potential diagnosis for the human doctor to consider. After the call, streamlined administration kicks in. The AI handles follow up scheduling, sends medication reminders, and processes insurance, cutting through the complex bureaucracy that often frustrate patients. Finally, for chronic conditions, it enables continuous monitoring. The AI can check in via the app, track key metrics, and flag potential complicated situations early, enabling preemptive care. The clear value here is not replacing doctors, but making the entire healthcare system more efficient, accessible, and convenient. Now, to fully appreciate how novel AI Agent Hospital is, it helps to compare it to other advanced healthcare technologies. Now, take a look at the table that you have on your screen. VR AR training platforms like SimX or Body Interact, the goal is different. In VR systems, the human is the trainee. In Agent Hospital, the AI is the primary trainee. The simulation is an engine for its evolution. And contrasting it with digital twin platforms, we see another key difference. A digital twin is a high fidelity model of a specific real patient used for personalized predictions. Agent Hospital is a model of a system, a generalized archetypal hospital. Its goal is to generate systemic, generalized medical intelligence, not make predictions for one individual. As the table shows you, its focus on the autonomous evolution of AI agents through a generative simulation sets it in a class of its own. The immense ambition of this project is matched only by the scale of the ethical and societal challenges it presents. Transitioning it from the controlled simulation to a real world clinical tool requires navigating some very difficult frontiers. There are four major challenges that we must confront. First is accountability and liability. If an autonomous AI makes a mistake that harms a patient, who is responsible? The developers, the hospital, the human doctors who oversaw it? The black box nature of advanced AI, where even its creators can't fully explain its reasoning, makes this an incredibly complex legal and ethical problem. Second is algorithmic bias. The simulation based approach cleverly avoids inheriting bias from flawed real world data, but it does not eliminate the risk. The danger is that the initial medical knowledge bases used to generate the virtual patients might underrepresent certain demographic groups. If that happens, the AI could train itself into a state of synthetic inequity, becoming highly proficient for the majority population but systematically less accurate for minorities. Third, data privacy and security. Centralizing sensitive healthcare data creates a high value target for cyber attacks. Furthermore, China's legal framework for data governance presents unique considerations that will require exceptional transparency to build international trust. Finally, and perhaps most importantly, the human element. Healthcare is rooted in empathy, in compassion, and nuanced communication, things an AI cannot generally replicate. As one of the project's leaders aptly put it, medicine is a science of love and an art of warmth. Over reliance on this technology could lead to depersonalized patient experience and even an erosion of human doctors' own critical thinking skills. Now, despite these challenges, the potential upside is enormous. It stands to transform medical education, providing a scalable, risk free training environment that could become a standard part of medical school curriculum worldwide, creating a new generation of AI collaborative physicians. The economic impact could be significant by automating routine tasks and enabling early preventative interventions that can lower costs for both hospitals and patients while extending the reach of specialists to underserved communities. And its global trajectory is already taking shape. The project has received cooperation requests from around the world, positioning it as a new benchmark for digital health and a potential blueprint for countries looking to build more equitable and resilient healthcare systems with limited resources. To conclude, the Agent Hospital is a testament to incredible technological ambition. Its core innovations offer a powerful new path for creating sophisticated medical intelligence at a scale and speed that we have never seen before. With that, we come to the end of the show. Thank you for watching. Like, share, subscribe, and support our work by joining us as a member.